Some people say that the biggest bug or procedural problem in modern mathematics is division by zero. You probably expect that this video will explain why these operations are impossible. Instead, it'll show you how to multiply and divide by zero and by infinity quite legally. My name is Eric Baird and you are watching True Physics. Modern physics sometimes throws up equations that contain combinations of zeros and infinities. If calculated in a single stage, the zeros can cancel out. 10 over 0 divided by 5 over 0 is just 2. But if calculated separately, school math tells us that 10 over 0 gives infinity, and so does 5 over 0. One unspecified infinite number divided by another gives us an answer that is undefined. We need a simple way to keep track of how big or small these infinities really are. First, we need to define some new numbers and notation. Rather than saying that all infinite numbers equal infinity, we define a reference infinity properly. We define unit infinity as 1 divided by unit 0 and unit 0 as 1 divided by unit infinity. For now, we'll just use square brackets to denote these. From here onwards, when we say 0 or infinity, we'll be referring to these exact entities. We can write all conventional numbers on a standard continuous number line. Everything on this unit number line is scaled by 1. However, this standard line doesn't include infinity as a specific location. To handle infinities, we add a second number line stacked just above it. This new upper line contains exactly the same numbers, but everything here is scaled by unit infinity. Similarly, we add a third line below scaled by unit 0. This vertical stack creates a framework for legal operations. Multiplying a number by unit infinity, or dividing it by unit 0, moves you up one level. Conversely, dividing by unit infinity, or multiplying by unit 0, moves you down a level, keeping perfect track of your scale. If we multiply 5 by infinity, it moves up to the unit infinity number line. Multiply by infinity again, and it moves further up to the infinity squared number line. Similarly, if we multiply a number on the 0 number line by 0, it moves down again to a further 0 squared number line below. There are an infinite number of these number lines available. Let's walk through a practical example. 5 divided by unit 0 plus 2 divided by unit 0, all divided by 2 times unit infinity. First we evaluate the numerator. 5 divided by unit 0 shifts up to become exactly 5 unit infinity. Similarly, 2 divided by 0 is 2 unit infinity. Added together on the upper number line, we get 7 unit infinity. Next we divide this result by the scalar number 2. 7 unit infinity divided by 2 moves us to 3.5 unit infinity. Finally, we must divide by the remaining unit infinity from our denominator. This operation perfectly cancels out the infinity terms, shifting our value straight back down to the standard number line. We are left with the final exact answer of 3.5. No undefined errors, just clean, traceable math. This system of stacked number lines gives us a simple visual way to handle infinities and zeros. It works wonderfully for basic cases, allowing us to track the relative sizes of these undefined values. Credit for this method probably goes to mathematician Abraham Robinson, who published a paper on non-standard analysis in the early 1960s. This system is mathematically similar to the way we already deal with complex numbers, but instead of adding a 90-degree vertical axis for imaginary numbers, we use stacked parallel lines to represent different scales of infinity and 0. And that's really all there is to it. But before we go, a challenge question. According to this system, what's the answer to infinity times 0? Leave your answer in the comments below, and don't forget to subscribe.